Hello everyone, welcome to OOkul. So let's continue this journey of theory of machines with the simple mechanisms part 2. Okay, so before proceeding further, let me remind you, if you haven't subscribed to our channel, please do it at the earliest and also press the bell icon so that you can get the notifications of our newly uploaded videos. Okay, so let us begin with this topic of degrees of freedom. Okay, very important topic, degrees of freedom, also known as mobility. So what is it? Let us see. It is the minimum number of independent variables, that are required to define the position or motion of the system is known as the degree of freedom of that system. Okay, so what is it? It is the minimum number of independent variables that are required to define the position or motion of the system is known as degrees of freedom. Okay, now if the position of any element with respect to time is known, then its motion can be defined. Okay, absolutely correct. Or if the motion of any element is known, then its position with respect to time can be determined. Clear? अगर पोजीशन पता है टाइम के साथ तो मोशन डिफाइन किया जा सकता है, अगर मोशन पता है तो पोजीशन डिफाइन की जा सकती है with respect to time. Hence, position and motion are analogous terms. Okay, now let us see what do we mean by or how we calculate the degrees of freedom. Okay, so if we talk about a general case, a very general case of a space that is in a 3D, we have total number of motions that are possible, maximum number of motions that are possible are 6. Okay, that 6 can be translational motions along x, y and z axis, so there becomes 3 translational motion. Okay, plus about all of these 3 axes the rotational motion, that is 3 rotational motions, so total becomes 6. Okay, so total number of motions that are possible is equal to 6, that is 3 translational plus 3 rotational. This is the maximum number of motions. Okay, now minus restraints. Restraints means number of those motions which are not possible, or you can say the restrictions. Clear? Number of motions which are not possible, or you can say the restrictions. Okay, now you think of yourself, it's a very general example, you think of yourself that you are living at home. Okay, so you have many restrictions, okay. When you move on to some PG or some hostel, you have a fewer restrictions, but there are some restrictions which you have to follow. But when you take a separate room outside, when you rent a room or when you live on your own, then the restrictions are very minimal. So as you can see, as the restrictions are decreasing, as the number of restrictions or restraints are decreasing, you see your freedom is increasing. Okay, your freedom is increasing, that means your degree of freedom is increasing. So your restrictions, less the number of restrictions, more will be the degree of freedom, or more will be the restrictions, less will be the degree of freedom. Okay, so please remember, degree of freedom in 3D is given by 6 minus restraints, that is number of those motions which are not possible. Okay, next comes, let us see the examples through some of the pairs, like turning pair. Turning pair have 5 restrictions. As of you know that this is a turning pair. So this turning pair can only rotate about this point. Okay, this can only rotate about this point. It cannot do anything else than this. So all other motions, that is 3 translational motion plus 2 rotational motions, are restricted. Okay, these are restricted for your turning pair. So it has got 5 restraints. So its degree of freedom becomes equal to 1. Clearly? Similarly, for a lower pair, the degree of freedom is equal to 1. Lower pair means which have surface contact. Okay, please remember this, we have discussed in the previous class. Lower pair means degree of freedom equal to 1. Okay, except the spherical pair. Spherical pair has a degree of freedom 3. Okay, spherical pair also known as a 3-dimensional rotation. Okay, for higher pairs which have point or a line contact, the degree of freedom is equal to 2. Okay, now let us see the degrees of freedom of 2-dimensional planar mechanism. This is more important because from this only the questions have been asked previously. So many questions have been asked. So please focus here. It says, now the maximum motions in this case becomes equal to 3. Suppose you have this x and y axis. So the two motions are, one is translational along x axis, one is translational along y axis, and about the third axis, that this is your axis, say z. So about this axis the rotation. Okay, the rotation about this z axis, or you can say the rotation in the xy plane. So you have 3 total motions, that is 2 translational plus 1 rotation. So these are the maximum number of motions. Okay, so for the degree of freedom to be calculated on our 2D, we will write it as 3 minus restraints. Okay, 3 minus restraints, or we will write it as 3 minus restrictions. Clear? Now see, if the total number of links are L, okay, and we know that one link must be fixed because that we discussed that how we obtain a mechanism from a kinematic chain. So if one link is fixed, then the total number of movable links become equal to L minus 1. Clear? Now, if number of binary joints equal to J and the number of higher pairs equal to H. Clear? So we have already seen in a 2D the maximum motions of each link is equal to 3. Therefore, maximum motions of L minus 1 link will be equal to 3 into L minus 1. Correct? Then motions restricted of each binary joint. Okay, because you know, suppose you take the case of the turning pair only. This is a binary joint. In a 3D, only one motion is possible. Total can be 3 in a 2D. Okay, only one motion is possible. So that means restrictions for a binary joint is equal to 2. Okay, for each binary joint. And we have J such binary joints. So motion restricted of J binary joints will be equal to 2J. Clear? Then the motion restricted of each higher pair is equal to 1. Because we have seen that the degree of freedom of the higher pair in a 2D is equal to 2. So it has got one restrictions of each higher pair. But we have H such higher pairs. So the motion restricted of H higher pairs will be equal to H. Clear? So therefore, the degree of freedom of any planar mechanism can be given by, planar mechanism means a 2D mechanism. Okay, in a 2D we are talking. That is F equal to 3 into L minus 1. These are the maximum motions possible minus 2J minus H. These are basically your restrictions. Clear? Then, so this can be written as F is equal to 3 into L minus 1 minus 2J minus H minus FR, where this FR is the number of those motions which are not the part of the mechanism. Okay, and this equation is only known as your Kurzbach's equation. Okay, Kurzbach's equation. Please remember that is F equal to 3 into L minus 1 minus 2J minus H. Very important equation. Okay, and we talk about the FR, that is your redundant motion, the degree of freedom of a redundant link. See this mechanism. We have a 4-link mechanism. In this 3-link, the motion of this 3-link is possible even without the motion of either of the input link or the output link. But this can rotate about between these points, okay, or these bearings you can say. Okay, so the motion of this is not influenced either by your input or by your output link. So this becomes your redundant link, and the motion of this link will not be influencing your degrees of freedom of the system. Okay, say, so if you remove this, we remove that link and we simply join these 3 links as this much. So still we get your degree of freedom will remain the same. Okay, so let us say here in this example I am talking about, we have the total links as 4. Okay, the number of binary joints, okay, the number of binary joints are equal to how much? This is 1, this is another, second, third and 4. Okay, and we have H, that is higher pair is equal to 0, and we have say FR is equal to 1. So if we find out the degree of freedom, that is 3 into L minus 1, that is 3 minus 2 into J minus 1. So it becomes equal to 3 minus 3 is 9, 3 into 3 is 9, 9 minus 8 minus 1. So this becomes equal to 0. Okay, and now see, now simply if we do it this way, here we have your number of links equal to 3. Okay, binary joint equal to 3, higher pair equal to 0, and FR is also equal to 0. So still if we use that equation, the Kurzbach one, that is 3 into 3 minus 1, that is 2, minus 2 into 3. Okay, so this becomes 6 minus 6, again becomes equal to 0. So from this we can understand that even if we remove the link, that's a link which was not the part of the mechanism, the motion of whose motion was not the part of the mechanism. So even if we remove that link, our degree of freedom of the system does not change. That means that sort of a link is known as your redundant link. Clear? So here it is written, if the motion of any link in a kinematic chain is possible without the motion of either input or output links, then that link is known as redundant link. Clear? So as I have shown there, the same example is here also. You can use it yourself and you can see that the degree of freedom for both of them will come out to be 0. Clear? Next, structure or frame. What is a structure or a frame? Mechanism whose degree of freedom is equal to 0. Okay, this is, we have just now seen for this sort of mechanism, the degree of freedom was coming out to be 0. So this is known as a structure or a frame. Okay, what is a superstructure? Mechanism whose degree of freedom is less than 0. It is also known as an indeterminate structure. Please remember these conditions. Okay, degree of freedom equal to 0 is a structure or a frame, is less than 0 is a superstructure, and the superstructures have very high load bearing capacity. So if we we use this example, we see here that your total number of links are equal to how much? This is one link, this is second, this is third, and this is one more link, this is fourth link. Okay, so this is your fourth link. Yes, this is link 4. The number of binary joints are equal to how much? This is one binary joint, this is another binary joint, this is another binary joint, this is another binary joint, and this is another binary joint. So we have total 5 binary joints. Okay, higher pair is, there is no higher pair, there is no FR. Okay, so if we find out the degree of freedom of this, that is 3 into L minus 1. 3 into L minus 1, that is 3 into 3 minus 2 into J, that is 5. So this becomes 9 minus 10, that is equal to minus 1. Okay, so we can see here that the degree of freedom of this mechanism is coming out to be less than 0. So it is your superstructure, and please remember that the superstructure have very high load bearing capacity. Next, kinematic chain. Kinematic chain is a mechanism whose degree of freedom is equal to 1. Please remember whose degree of freedom is equal to 1. See here, we have the total number of links as 4, the number of binary joints as equal to how much? 1, 2, 3 and 4. Okay, there is no higher pair, there is no FR. Okay, so put it to 0. So use this equation, Kurzbach 1, that is 3 into 3, L minus 1 is 3. Okay, minus 2 into 4. Okay, so this becomes 9 minus 8, 1. So we have for this mechanism the degree of freedom coming out to be equal to 1. So this is your kinematic chain. Okay, unconstrained chain, mechanism whose degree of freedom is more than 1. Okay, whose degree of freedom is more than 1. Here you can see you have total number of links as 5. Okay, links as 5, your binary joints as equal to 1, 2, 3, 4, 5. Okay, so these are 5, H is equal to 0, FR equal to 0. So using the Kurzbach equation, 3 into L minus 1, that is 4, minus 2 into 5. So this is 12 minus 10, that is equal to 2. So for this mechanism, the degree of freedom is 2, which is greater than 1. So this mechanism is equal to your unconstrained chain. Okay, so degree of freedom is the number of inputs required to obtain the constrained output. Please remember this. Okay, degree of freedom is nothing but it is the number of freedom, it is the number of inputs required to obtain the constrained output. Clear? Now let us see some of the important cases like this you have given. Okay, I will write this figure as A and this figure as B. Now what you have to do, as you now know the concept of the links, the joints, what we have discussed in the previous lecture, and today we have discussed about the Kurzbach equation for finding out the degrees of freedom of the 2D mechanism or the planar mechanism. So please solve these two questions, solve these two cases and write your answer in the comment section below so that we can understand that how much you have understood this concept of degrees of freedom. Okay, now a spring as a link. If your spring is given as a link, that we can change it to this way. Okay, please remember if there is a spring given in this way, then we can make it equivalent to this sort of link. Okay, now we come to the Gruebler's equation. Very important equation, Gruebler's equation. See how we are evolving into this topic. Okay, how we are evolving into this topic. The previous class was a very simple one. We understood the different types of links, the different types of joints, the different types of motions. Today we step up one step ahead. Okay, we moved one step ahead. We see about the concepts of degree of freedom and all. Now we will move one step more forward and we will see that what is the Gruebler equation and how we are getting into that 4-bar mechanisms. Okay, let us see this. See, in those mechanisms where degree of freedom is 1, please remember that F is equal to 1 and consisting only of lower pairs. That means higher pair is equal to 0 and degree of freedom is equal to 1. He applied the Kurzbach equation. Who applied this? Gruebler. He applied the Kurzbach equation. Okay, see, F is equal to 3 into L minus 1 minus 2J minus H. So he wrote F is equal to 1. Okay, 3L minus 3 minus 2J minus H is equal to 0. Okay, so you have this 3L minus 2J must be equal to 4. Clear? So now for this equation to be satisfied, there are two even numbers. Correct? 2J is always even, 4 is a even. So this 3L must also be a even. Okay, and 3L will be even only when your L is even. Correct? Then if L is equal to 2, what is the lowest even number? That is 2. But if the L is equal to 2, that is the number of link is equal to 2, then the chain will not be a closed chain. Okay, it is not possible. So we move on to the second lowest number other than greater than 2, that is 4. Okay, so that is 4. So to obtain a mechanism which provides a constrained motion, because we already see what is a constrained motion or what is a kinematic chain, in which the condition was that it should be a closed chain. Okay, so which provides a constrained motion and consists only of lower pairs. The minimum number of links required are 4. From here only came the concept of simple mechanisms. All those mechanisms with lower pairs and have 4 links, they are known as your simple mechanism. So there are different types of simple mechanisms like your 4-bar mechanism, single slider crank mechanism, double slider crank mechanism. Okay, so all those we are going to discuss in the next subjects, in the next classes. Okay, so thank you for being a part of this class, being a patient listener. So please like these videos, share them with your friends and colleagues so that others can also get benefited out of it. Okay, and if you have any queries, any comments, any doubts regarding anything that we are posting, you can write to us on the comment section below, and also you can get in touch with us through our Facebook page, Twitter page, Telegram channel, website and the email ID. All the links have been provided to you in the description box below. Okay, so stay tuned for the next video. That will be very important of this only, that is the simple mechanism. We will be starting with the 4-bar mechanisms and the concepts of the inversions of the 4-bar mechanisms. Okay, so thank you for being a part of this class. See you in the next class. Thank you and have a nice day.